Thank you, everybody. My name is Alex Rodling. I'm with the MySQL team, and I'd welcome you to the MySQL Performance Tuning Best Practices session. And with us today is Philip Antoniades. He runs our pre-sales consulting team, so he's had a lot of experience dealing with customers and architecture design, performance tuning, etc. So I'll introduce Phil. Thank you.
Thanks. Hi, everybody. So I am going to talk about performance tuning fundamentals. It is called fundamentals, so if you are already somebody who's been working for years as a MySQL DBA, I am expecting you to learn nothing from this. If you are coming to MySQL from another database, or if you are new to databases in general, then there's a lot of information here that you should get about the basics of how MySQL performance tuning works and some do's and don'ts. And I'll try and leave you with some of those things. So I'm going to give you just an overview and kind of just some general practices for what everybody should know about performance tuning. And then I'll get into some specific areas of performance tuning. Some of them are specific to MySQL, and some of them are just general good practices with databases. So let's go through the main thing about this is that this is going to be a technical talk. So again, if you're looking for, it's going to be a technical talk that is not particularly a deep technical talk. So if you are looking for more information on it, I'm going to have links throughout, and the slides will be available after. So you'll be able to get all these links of how to find out more information about MySQL. So where a lot of people start is they will ask, what is the perfect hardware to run MySQL on? It's kind of a fluid question. It's always changing a little bit. Right now, like the 4 to 8 core systems are kind of the sweet spot for MySQL. MySQL kind of grew up as the database of the lone guy in the garage working on a web application, so it's typically been best suited on small hardware. That's obviously been changing as we were owned by Sun, which obviously gave us access to quite a lot of large hardware, and now Oracle knows quite a bit about that. So in the next release, actually, there are some significant performance enhancements that are specifically involved around getting MySQL to scale well into the much higher cores, into the large multi-core architectures and large amounts of multiple processors. So some of the things that you should know about MySQL is that MySQL, there's a number of things that when you start MySQL, there's a file called my.cnf or my.ini on Windows that has all the performance configurations of your machine. They're called the system variables, and at a MySQL command prompt you can do show variables, and you'll get this scrolling list of all the different parameters, most of which you can change. Some of them are there to give you information about the system that you're working on. To be able to change them, you can either change them in the my.whichever and then restart the system, or you can use a set global or set session or just set from one of your clients. So you can do that to make changes and see how they're working in production. Well, not in production, but you can see how they're working on the running system and then actually make the change into the configuration file so that that change will survive a restart. Then again, the next thing that you will need to know is how to look at the status of your current server. Similar to the system variables, like show variables, you have a show status. That will give you another scrolling display of how many times various commands have been executed, how many times full joins have been created, and things of that nature throughout the system. You can use that when a system's been up for a while. You usually have a fair amount of information with which you're able to find out exactly what's going on in your configuration, what you need to be tuning. So for the first thing to do if you really are tuning a system that you're new on is to enable the slow query log. The slow query log is exactly what it sounds like. Whenever a query is slow, meaning it's not able to use indexes, it takes more than X number of seconds, there's a configurable parameter for that, then it is going to flag that and put the actual query itself as well as the execution time inside of this field, inside of this file. So to back up a little bit, let's talk about some of the rules of performance tuning. You don't start out by making changes in production. That's a good fundamental for actually any sort of endeavor you're going on as a database engineer. You want to have a good benchmark, a reliable load. You want to change only one thing at a time. You want to be able to have reproducible results. So you don't want to just say, well, it looks like this could be different, and this could be higher, and this could be lower, and now let's see how that all goes. You want to move very methodically. It's a very slow process. There's a number of tools that you can use. to do this. On most operating systems will have a way to measure how I/O is going through the system, how the processor is behaving, how to track how various processes are behaving, and how many resources they're using. You'll want to know what those are for the operating system that you're using. So then going back to a benchmark, there's a number of benchmarking tools. MySQL SLAP was introduced in MySQL 5.1. It's probably the easiest to use and most rudimentary. I'd probably recommend Sysbench. There's a number of other ones that are listed on this, but with all of them, they basically will rerun a certain number of queries. In some cases, they'll generate random queries. In some cases, they'll let you specify a query set, and then they'll report back on exactly how long those things took and at what point the database is no longer able to process things at the level that you were hoping. So now getting into some MySQL specifics. One of the things about MySQL is that MySQL supports different storage engines. The storage engine is basically how the server interacts with the underlying storage system. So for example, that could mean, in a very simple example, you could be talking about a memory storage engine where the server effectively doesn't interact with the storage system. It keeps everything in memory. Cluster is actually interfaces with MySQL as a storage system. So cluster means that instead of your MySQL query being processed in the I/O being done on the local machine, it is actually being farmed out to this cluster of data nodes. The two most popular storage engines, however, are MyISAM and InnoDB. And they're both, and now they are both used, both developed and created in-house. Originally, InnoDB came to us by way of another company, and then that other company became Oracle, and then we became Oracle. So it's all come back to the well. So InnoDB, if you are, again, coming to MySQL from another database, InnoDB is the one that's going to look the most familiar to you. It is fully ACID compliant. It's completely transactional. It uses table spaces on disk. It looks like a database to just about everybody. One of the particular things about InnoDB's design that I will stress here is that InnoDB is always clustered on the primary key. By clustered, I mean that the data in the table is always in primary key order. So if you don't create a primary key, it will create one for you that you will just never be able to access. So you might as well always create a primary key. That primary key also should be something that will not be changing. That's a good rule for databases in general. Theoretically, your primary key is immutable, and it is something relevant to the order of the data, and obviously unique. So we'll talk about MyISAM in a minute, but MyISAM uses a key cache, and InnoDB actually has a much larger cache that it uses for both data and indexes. It's called the InnoDB buffer pool size, and well, it's called the InnoDB buffer pool. But the InnoDB buffer pool size on a system that is using only InnoDB, this should be the bulk of your available memory. 70 to 80% of available memory is absolutely not unusual. I've seen systems that are closer to 90% of available memory given over to InnoDB. Obviously, when you get into areas where you're mixing storage engines, if you have half of your data in InnoDB and half of your data in MyISAM, it becomes much more complicated. But the basics are that in an all InnoDB system, you want to have the bulk of your memory just going into this one system variable. If your system supports direct I/O, you should tell InnoDB that it is free to use it as well. And there's a number of things that you can set, and a number of ways that you can monitor just InnoDB in particular. It's almost a completely separate database in and of itself. It's got a lot of things that you can tune, a lot of things that you can monitor. So one of the things, again, this is just a general best practice for any database system. The hot data, that is the data that you use most often, is what you want to be finding in memory. You'll find that if you have a large enough data pool, you will get to database nirvana, which is that all of your data is in RAM. But barring that, you want to be able to identify the data that is going to be used most frequently and make sure that that is being cached well. So moving over to MyISAM. MyISAM's a different type of animal. It's not as familiar to the average database user as InnoDB. MyISAM is, as the name indicates, it's based on an indent sequential access method storage, and MyISAM was originally the first storage engine for MySQL, and it stores data on disk. It relies a lot more than other databases on the actual operating system, which is in some ways a very good thing. I mean, a lot of Oracle and a lot of the traditional RDBMSs came about when the operating system really couldn't be trusted to do your data caching and data storage, and now operating systems have come a long way. So, I mean, it can help that you have this close relationship with the operating system, but it is the main thing about MyISAM, is that it is non-transactional. So you're not going to get the ACID transactions. You're not going to get the concurrent versioning that you would with InnoDB. So for very transactional loads, obviously transactional loads, you're going to have to be okay with the fact that your multiple things cannot be rolled back at a time, cannot be committed at once. But beyond that, you also, since you don't have the concurrency, MyISAM is not going to be a good choice if you have a lot of people doing updates and inserts with some special cases at the same time. MyISAM is very good for websites, however. If you're delivering unchanging content rapidly, multiple times, then it can be the best storage engine that's around. Its flaws all become virtues. But if you are using that, then, and if you're using some of its special features, it also has full text support. It does geospatial, it has some geospatial functions that you can use with MyISAM data. It is primarily tuned as InnoDB has this cache that is the one main cache. MyISAM has a cache that is important, but not entirely important, called the key buffer cache. You use it for a lot of your memory because, as the name indicates, it's only caching keys. The rest of it is going to be the data, and we're actually going to be relying on the operating system to know how to properly use its memory to do the data caching. Now then, you can define multiple of these key buffers. You can, and you can actually pin them into memory if you need to. You can pre-create them if you need to. There's some variables there. But in addition to those main things, there's also a number of ways to monitor how this key cache is doing. And you can see a lot of these things here on the screen. There's a lot of these different monitors. A lot of these system status variables that you can look at that'll tell you exactly what the key cache is doing and what is not being cached. And you can see some of the math that you do here to find out exactly what your hit rates are and things like that. I will mention at this juncture that one of the things that MySQL Enterprise will give you is the MySQL Enterprise Monitor, which will actually take the arithmetic out of a lot of these things for you. This is not a presentation on the Enterprise Monitor, but if you want to learn about all these different things and these ways to actually keep track of all the things that are going on inside the server, and then you decide that you don't actually want to have to follow them, you can use the Enterprise Monitor, and it actually gives you the GUI display that just says, here's your overall hit rates, here's what this is doing, and over time this has gotten better, over time this has gotten worse, and those kinds of things. You can find out much more about that on our website. So the rule of thumb in MySQL's threading is that one connection becomes one thread. So there's a number of different things, there's a number of different variables that you can set that are allocated with each connection. They're called session variables. So the session variables, there'll be things that that will get created and reused several times depending upon your connection pooling. But you don't want to set any of those too high, obviously, because all of those are going to wind up being multiplied by the number of connections that you have. So if you have one of these connection variables and you decide, well, I want to have a swap buffer for every connection that's going to be 8K, that's fine. If you want to set it to be 64 meg, I hope you have either a whole lot of memory on your system, or you're not expecting more than 10 people or so to ever be using the computer at once. So there is, again, in performance tuning, I would be remiss not to mention the query cache. It is, some people say that it's the single best thing about MySQL. Some people say that it is what you should absolutely never use. It's an extremely simple animal. The query cache, when enabled, just takes every query that comes in and the result set and caches them. So the next time that exact query comes in, if nothing has changed and it hasn't had to invalidate that result set, it can just bypass the parsing and all that stuff and just deliver the result set. That's wonderful if it works for you. And it works for you if, number one, your queries are going to be identical, as in select with a capital S and select with a lowercase s are not identical queries, even if everything else is the same. Because it's just looking at the straight binary, is this the exact same query that has come in the last time? Also, if your data is not changing that fast, because remember, you change data in that table, all the queries that were based on that table get invalidated. So there's a number of different things that you have to meet to be able to use this query cache. If you can, there are people that will say that it will give you an 80%, if you've got the right thing, just like with MyISAM. If you're in that sweet spot for the query cache, then you will get tremendous performance enhancements, because there will be all these different queries that will have to do no parsing, no I/O, no anything. They're just recognizing the form of the query that comes in and then sending back the results. The best practice is probably, if you want to be able to figure out exactly how the query cache is going to work for you, the best practice in general is to set the query cache to demand. You can see that there's 3 forms. There's always on, there's always off, and there's only cache when I tell you to cache it. So if you use that third one, then basically your developers just have to remember to put in that _SQL_cache for all the queries that they know are queries that come in the same binary format for data that is slow changing. And then you'll get the query cache benefits on the right places. You won't get any real accidental savings from it, but you'll get the benefits of it. So a little bit about indexes. I won't go into the basics of databases. This is just a fundamental talk. I guess it's not more than fundamental. But indexes allow for faster access to data. The basic idea is that instead of having the whole table and you look at what's in the table, you have this index that is just a piece of the table, and it has a pointer to where the rest of the information that row is identified by is. So you can you can scan through a very short thing rather than scanning through a very wide thing. You can create indexes. You can create multi-column indexes in MySQL. You can create indexes for various types. You can also create partial indexes. So if you know that you have a 64-character field, but you know that just knowing the first 10 characters are enough to make it unique, you can create an index that is just on those first 10 characters. And obviously, the rule with databases is smaller is always better. You always want to have the smaller type when you're creating your schema. You always want to have the shorter column when you're creating your index or whatever. If you can make the amount that you're indexing on be shorter still than the amount that you're storing, so much the better. So there's a few things about this. You can use indexes. Indexes can be used by the order by section of a query as well as by the where. They generally can't be used with both. So you'll see an example here that if you're going to, actually I think this example is on the next one. So this is a join example. So if you want to have a join where you're joining XA from XY, joining XY, A and XY. So once you filter it, you need an index on only one column. Then I don't understand where this example is going. So you're going to pick the shortest of the available indexes, and from there you'll be able to scan through the table and find out exactly where you need to go. So this is the example that I was talking about. If you want to be able to get a name, if you want to be able to order by name, and you're selecting a range, then you can still use that index to order the entire range and get your results sorted. However, if you're using an index to be able to pull out a specific record, that index is now not going to be able to be used. You'll have to do a file sort to actually sort the rest of the result set around that. So it's important to note exactly when sometimes, even though you may think that an index is going to give you a full advantage, the index is really, order bys are really kind of a tricky area for indexes. They're frequently going to result in file sorts in MySQL. So MySQL can also use partial indexes. So if you have, as it says here, an index on column 1, column 2, column 3, you may need an additional index on just column 3 if you want one of those, but you don't need an additional index on just column 1 because you can use just the first piece of that index. Nor do you need a compound index on column 1, column 2, because again, you can use the first piece of that 3-column index. So that's another thing that you will not need to do. Also keeping to the rule of keeping your indexes small. If you do have very wide, we generally tend to avoid at all costs making very wide indexes. So if you do have a very wide text field that does need to be indexed, a smarter way to do that will be to use some method like creating an MD5 or something like that. The MD5 is a function in MySQL to create a hash of it that'll be a much shorter value, and then whenever you want to look for, if you ever want to seek for that thing inside the table, you can say seek where hash that and then find me the value. Now then, if you want to find out how your queries are going to be performing, the simple way to do that is with the explain keyword, and it's quite simple. You just take the select statement that you're going to be doing, and you put the word explain before it, and it gives you a listing of exactly how of exactly what tables are going to be used, how they're going to be used, and what it thinks it needs to do to create the proper seeking order. And from there, you can generally find out exactly what indexes can be used to improve that order. And I'm going to go through a quick reference of that here. And again, more links here. I'm sorry that this is a bit of an eye strain, but this is the columnar output of a select statement. So I will read this for you because I don't think you're going to be able to. So we're doing a select. This is out of the world database, the Sequila database. Sorry, the world database, yeah. That you can download from our site. But you can see that it's doing that. There's 3 rows here. That is from left to right. They're doing the ID of what the server is calling the table, the select type, the table as it's referenced in the query, the type that it's doing from there, the possible keys that are available, the key that is being used, the length of that key, etc., etc. So the main things to note here is if you can't read is that in the world database by default, the country and city databases do not have indexes on them. So it's basically, so what you're doing here is you're doing a select name. You can see the select statement up above. Select name, population, language from country as C, city as Y, country language as L, and you're looking for the ones where you're lining them up on the country code, and the country name has to be Macau. So in this example here, the number of rows that it would have to examine, it says it would have to do a full scan of basically city and country, so it's going to need to look at 239 rows in the country table, 4,079 in the city table, and then 9 rows in the final one where it is able to break it down by the primary key. If we do, sorry, I'm missing a slide here. So if we add an index to both country and to city, then actually the two numbers, the 239 and the 4079, both become 1. So we actually don't have to do anything else. I'm just going to see if that slide is just hidden. Yeah, it is. Okay. So then here's what it looks like if you actually run these 2 statements on it. Alter table country, add an index on name. Alter table city, add an index on name. Then you can see this, fortunately, in somewhat larger font. And that same select statement, then you can see how the last time you had unfortunately, the larger font doesn't line up as well. The second from the left column where you see a 1 and a 1 and then a 1, that is the number of rows that have to be examined. So whereas the original cost was that it would have to examine 2,239 rows in one table times 4,079 times 9, so before you were asking the server to do a little close to 9 million rows of I/O, and then the second time the cost becomes 1 times 1 times 9, so it becomes 9 rows of I/O. As you can imagine, that's going to be orders of magnitude faster, although in a table that's reading directly out of memory, you might not notice that as immediately, but when you start doing these queries thousands of times a second, and when you start doing them with larger data sets, it winds up being staggering. And this could be the difference between your system falling down or humming along fast. So again, another note to always have your slow query log on until you move into production. As part of the enterprise service, you can also get the query analyzer that will actually give you an even more detailed look, drill down into your queries, but at a minimum, you'll want to have the slow query logs that you can catch the ones that are slow. There's a status, you can also log queries that don't use indexes. That's part of the slow query log to begin with. And then understand and use explain. And again, I've got a link to that. I've got a link to the query analyzer as well. Like I said, I'd be happy to talk to any of you more about exactly what comes in the enterprise monitor and with the enterprise package. But again, if you have that, then you really don't need to know all the stuff that I'm presenting today. So one of the things that people don't realize about MySQL is that the in clause in MySQL is quite fast. You can give an in clause an enormous number of specific rows, and you're essentially creating a table on the fly, and it'll do that. It'll do that search for you as fast as it would in a table. So another thing is you can do searches. You can do kind of wildcard searches in SQL. The % sign is the wildcard. But one of the things to note is that you don't want to ever, even if you have an index field, if you're going to put the wildcard on the left side of your value, then you are never going to use an index. It is just going to do the search, and it's going to have to do a full scan of all the rows in that table for the obvious reason that you don't that indexes work from left to right in English. It is important to learn how to use unions, but I'm not going to get into them here. Again, I've said this again and again, but the size of your schema, just like the size of your indexes and the size of your queries, the smaller ones are better. You don't want to automatically go for a large value because you think that's what you could need at some point. You want to go for the smallest value that could possibly handle all the data that you're going to put in that column. You can use procedure analyze. It's one of the procedures that comes with it to be able to determine in a known database. Once you've already got your data in there, you can find out exactly what size your columns need to be and how many of them are how far over the size that they need to be. There are also custom types that MySQL has built into it. These deviate from the SQL standard, but you can use things like enumerated values to create just a set of actually almost, they're kind of like constants in a lot of different programming languages where you're just going to say like black, blue, green. If you know that those are the only three options, instead of having a car 5 where you're only going to be putting black, blue, and green, you can just say create an enumerated set of black, blue, and green. Internally, MySQL is probably going to call these 0, 1, and 2. But then you're going to have just a very clean, small integer column that you get to use the named values for. But internally, when that thing grows to be millions of rows, you'll find that you're saving gigabytes of space. And then large strings, again, similar to the way that I was talking about hashing URLs, you can also compress and uncompress strings if you know you're going to need to work with them. So here's some things that you should never do. This first example is specific to InnoDB, but it could really be true of just about anyone. if you ever do create table varchar32 as the primary key, every time you do that, a puppy dies. That's really one of the absolute cardinal sins of MySQL. And it's one of the ones that people pretty frequently do. You should never, doing select where a function of an indexed value, a function on an indexed value equals 20, that's never going to use an index. And you're going to, it's not quite as egregious an example, but it's still something you should just not do. And again, you should learn, read through the system variables and understand what they are. A lot of people will just look at like key buffer size. Well, that doesn't look like it's too important. It just has to do with keys, so we'll make that 4 megs. But read buffer size, we read all the time, so let's make that 32 megs. This is really just a quick way to crash your server. The key buffer, as I said before, is the one that holds all of the indexes for all the cached indexes for all of my ISAM, and the read buffer size is one of those ones that gets created for every connection that comes into the server. And then the final example is, again, selecting from an index value where the index is like wildcard, something else. There's no reason to have the index then, if that's the kind of searches you're going to be doing. You can do things with reverse indexes and things like that that can make that problem go away. But in general, that's something that you should avoid, or you should try and find a different way to make that work. Okay, well that's what I have for today. Are there any questions? All right, thank you very much.